două echipe care au luptat pentru România, au fost singurele participante anul trecut. Eu le numesc echipa mare, respectiv echipa mică, pe care am ales-o ca să facă simularea astăzi. Eu anul trecut numai clasa 7-a, a fost cea mai mică echipă din concurs și pot să vă spun că au rezistat eroic, punctajul fiind extrem de bun. Ceilalți, la semifinală, au fost pe locul întâi în lume, în mai mare punctaj. Am dorit să vă prezint echipa mică astăzi, pentru ca să vedeți că se poate și că se învață. Încă de când ești foarte un concurs pe care o simulare de concurs, vedeți astăzi, el va fi în limba engleză, deci exact forma pe care o are concursul în sine. Deci forma riguroasă, inclusiv jurizarea va fi făcută, să zicem, live. Felicităm copiii și ei o să vă una dintre probleme o să o încărcăm pe site-ul școlii ca să vedem în care să ajungeți. Mulțumesc mult de tot. Acum, invit în juriu colegii profesori de fizică și chimie, respectiv, pentru că e o orientare a concursului în acest sens. Deci, domnul profesor Carpala, doamna profesor Bogdaneanu, o să și pe nostru Dan Prudeanu și doamna profesoară Vlad. Că mine, în primul rând, este o simulare, deci, practic, nu se obține note de comentariile, le va face președintele juriului, care este o elevă a noastră, Ioana, care a făcut parte în juriul național anul trecut, fiind și coordonatoarea echipei mici. Deci Ioana a fost cel mai tânăr jurat din lume și a avut o intervenție absolut excepțională. Ea vă va prezenta și formatul concursului.
Bună tuturor! Ne pregătim să începem, dar înainte de asta vreau să vă spun câteva cuvinte despre structura concursului. În mod normal, un fight are loc între 3 echipe. Astăzi aveți în fața voastră doar o echipă, dar pentru a simula meciul, copiii s-au împărțit în 3 mini-echipe, respectiv Ioan va fi reporterul, apoi Luca va fi oponentul și în final Emma va fi viewerul. Și veți vedea cum are loc discuția între cei 3. Și ca să nu mai pierdem timpul, bineînțeles vom începe și, cum a spus doamna profesoară, vom vorbi în engleză ca să aveți adevărat sentimentul cursului. Așadar, now we'll start with the presentation of the reporter. You have 8 minutes, starting now.
To begin with, I would like to mention some aspects that I will ask you to take into account in the following presentation. Microwave ovens and chocolate are two fairly common things, which I'm sure you've all come across in your everyday life. I'm sure many people in this room use microwave ovens every single day to heat their food, and chocolate is of course a very useful ingredient in many of the existing recipes. But I don't think that you've asked yourself a question: if these two ordinary objects could lead to something revolutionary. My name is Ioan Pețan, and today I'm going to present you my problem for the IYNT competition entitled Chocolate and Speed Flight. Let's take a quick look at the statement of this problem. A visual method to measure the speed of light is to place a chocolate bar into a microwave oven until the chocolate starts to melt and measure the distance between hot spots. Study this effect and investigate of the method. As defined, the speed of light in a vacuum, also known as C, is a universal physical constant used in many calculations. Its value is estimated at 299,792,458 meters per second. And this is the formula that will help us establish the speed of light according to a microwave oven and a chocolate. C equals lambda multiplied by F, in which C is the speed of light measured in meters per second, lambda is the wavelength of light measured in meters, and F is the frequency at which light waves move, measured in hertz. But Why we can estimate the speed of light according to a microwave? Well, the answer is quite simple. Like light, microwaves are a form of electromagnetic radiation. Both light and microwaves travel at the exact same speed, but with different wavelengths and frequencies. This means that by measuring the wavelength and the frequency, we will obtain the speed of a wave, which corresponds, as we established a little bit earlier, to that of light. What are microwaves? Microwaves are oscillating electric and magnetic fields. The electric field is responsible for cooking our food every single day. But how do they do this? Well, first of all, most of the food we eat contains water, which is a polar molecule. The hydrogen and the oxygen have charges. This makes the water molecule behave like a diode. When an electric field is applied to the water molecule, it starts rotating due to the torque produced on the diode. The electric field oscillates continuously, keeping the water molecules oscillating and causing friction between them. A resonance cavity technique. Microwaves generated by a magnetron travel through a waveguide with the metal cavity of the oven. By conventionally aligning the parallel metal walls of the oven, the incoming microwaves are reflected by the walls and travel in opposite directions inside the oven. The size of the oven chooses so that the pits and tubes of the reflected wave line superpose with the incoming waves and form a standing wave. The standing wave fluctuates in time but does not propagate in space. And as you can see here, the formation of a standing wave, the red one, by superimposing two waves with the same wavelength but opposite directions, blue and green. Formation of hotspots and antinodes. The standing wave has two major points, namely nodes and antinodes. The node is the defining point of the lowest energy wire. The antinode is the point of maximum amplitude, the one with the highest energy transfer. The antinodes are the hottest part in the microwave. And with the help of the rotating plate, it manages to keep the food on its entire portion. Because of that, the first thing we'll do in this experiment is to make the plate stop rotating by taking the ring with the wheels out of the oven. Material and methods. For the following experiment, we will need the next materials. 16 bars of chocolate, 4 chocolate bars for each of the 4 exposure time, namely 15, 17, 19, and 20 seconds. A microwave with a standard model with a frequency of 2450 megahertz, a calculator, a caliper, and a ceramic plate. Method. The next step of my experiment is to place my chocolate bar on a ceramic plate and put it in the microwave for around 15 to 20 seconds for each of the 4 exposure times. Now, after taking the chocolate back, we can identify some melted parts, which indicate the exact location of the antinodes in the microwave. We can also see some solid parts, which indicate where the nodes are. And this is the moment when the caliper enters the experiment. We will measure the distance between 2 adjacent antinodes, which usually has values between 5.5 and 6.5 centimeters. Now, we will multiply the result by 2, resulting in the wavelength of light. And then we will divide it by 100 so that we can estimate our value in meters. The frequency is written on the back of the microwave. And as I specified earlier, the standard model means that the frequency will be 2450 megahertz, which means 2,450,000,000 hertz. And now we will introduce the obtained data into the formula from which everything started. C equals lambda multiplied by L. And these are the questions that we have established with the desire to obtain the greatest possible accuracy. Question number 1, how does the exposure time affect the error rate? Hypothesis number 1, the error rate decreases significantly with the increasing of the exposure time. Question number 2, what is the minimum number of measurements we need to obtain an accuracy of over 99%? And hypothesis number 2, at a certain number of repetitions, we will realize that the error rate will reach a value lower than 1%. As you can see in the statistics, for each of the 6 chocolate bars, I measured the distance between 2 adjacent antinodes, after which I found out the lambda and introduced the obtained values into the formula, resulting in the speed of light. After that, as I wrote below the table, I calculated the error rate and the accuracy. The error rate is obtained by dividing the difference between the measured value and the true value by the true value and then multiply the result by 100. Well, the accuracy percentage equals to the difference between 100% and the absolute value of the error rate. As you can see in our experiment, the mean of error rate decreased with the increase
increasing of exposure time and became close to zero after 19 seconds. But no significant differences among the exposure time categories, overlapping of the confidence interval. This means that in conclusion, hypothesis number 1 is rejected. Exposure time does not influence significantly the error rate. To answer the second question, I created this table in which I calculated the arithmetic mean from 1 repetition to 16 repetitions. Increasing the number of repetitions, we all know that the accuracy of the method also increases. For this reason, after I did the arithmetic mean for each of the above columns, I also calculated the error rate and the accuracy percentage using the formulas from the previous table. As expected, the accuracy of determination of the speed of light improved significantly by using the chocolate and the microwave with the increasing of the chocolate number. And accuracy greater than 99% was obtained after 10 repetitions. In conclusion, hypothesis 2 is accepted. The number of repetitions increasing significantly with the increasing of the number of repetitions. And here we have the sources of error. Human error when choosing the exact location of the hotspots, antinodes, could have used a thermal camera. Lack of variation of microwave frequency wavelength could have built my own microwave, too difficult, but it results in many errors. And the thickness and the length of the chocolate by which I mean the form. In conclusion, average values of accuracy percentage by using individual 16 chocolates repetition was 96.6%, which indicates a very good accuracy of the method because it's greater than 95%. Now, and by calculating the average of after using all of them is around 99.4%, which indicates an error rate lower than 1%. Exposure time does not influence significantly the error rate, as I specified. Hypothesis number 1 is rejected, and by increasing the number of repetitions of the experiment, the accuracy of the method also increases. Respectively, the average value of accuracy goes to 4 and more to 100% value. After 10 repetitions, the accuracy percentage becomes greater than 99%. This was my project. I hope you enjoyed it. Thank you for your attention. And here is the biography with the slides I used when I documented myself for this problem. No, it wouldn't, because the positioning of the chocolate in the microwave and the ingredients the chocolate bar contains will not influence the result. The wavelength will remain the same. The chocolate, we just use the chocolate as defined so that we can establish the speed of light in the measurements, but we could have also used cheese or any other material. The most important element in this experiment was the microwave oven, the microwaves, because the wavelength doesn't change.
How could you measure the hotspots more precisely?
Using the thermal camera, but unfortunately, as I stated, I realized it's too late and I couldn't.
Okay, is there a practical reason you chose to use the ceramic plate? You mentioned it in your presentation that you chose ceramic plate as a holder for the chocolate. Is there a practical reason?
This is a practical reason because they wouldn't influence the positioning of the antinodes. Because of ceramic plate, it wouldn't change the chemical quality of the chocolate.
Okay, thank you. And why did you only vary the time?
I could have varied a lot of different things, but I thought that time is the most precise and the most important of all of them. Because time is precise, it has data, certain numbers. Numbers of seconds, number of repetitions. Time, I think, is the most confident one and the most respected one in this problem.
Okay, and another question. How much more accurate do you think the results would have been if you used a thermal camera? For example, what would be the error rate if you use such a device?
I didn't investigate this method, but I'm sure that this thermal camera could have improved really good the study and the accuracy of the method.
Okay, do you think that the type of chocolate will affect the results?
As I specified, the ingredients of the chocolate bar will not influence the wavelength. The wavelength will remain the same because of the method.
Okay, thank you. That's it.
Thank you. We'll now move to the preparation of the opponent. In the competition, they will not
class, we should read it. A visual method to measure the speed of light is to place a chocolate bar in a microwave oven until chocolate starts to melt. Then you measure the distance between the hot spots. Study this effect and investigate the accuracy of the method. For the problem class, we think that the introduction was quite redundant and unnecessary for the understanding of the problem. This is why we think it needs improvement. The theoretical explanation was very good. He supported all his experiments using this theory. The setup and experiments were lacking. He could have used a thermal camera or more precise measurements. The correlation and conclusions were also well done. We think this because he correlated his results and had a good conclusion. For the theoretical part, the strong points, the presentation was logical, well structured, and had a good visual support. All of his theory and all of his experiments were supported by images. He had a good explanation of the physics behind the phenomenon. He explained how water is a bipolar molecule and its friction results in heat that so heats the food. The explanation of how the microwave works and how it cooks food. But for the weak points, he did not analyze the chemical structure and ingredients of the chocolate. In our opinion, it could be a parameter that could affect the results. And he had a repetitive explanation of the same terms in his introduction and theoretical part. For the experimental part, he had some strong points, had a very good interpretation of that data. After every experiment, he had a conclusion. The experiment reached clear results. After the experiments concluded, he had a table that organized his data. He had well-chosen materials. For example, he used a caliper, but as he mentioned, we think that a thermal camera could have improved his accuracy. He had a well-formulated hypothesis and experimental questions, which he in turn answered in his conclusions. Now, for the weak points, he didn't have much variation. He only varied the time. We think that other parameters such as the relation of the chocolate in the microwave and the chemical composition of the chocolate would have affected the results. He did not experimentally verify the frequency of the microwave. As we all know, after some time, microwaves tend to degrade and change. He did not take into consideration possible external factors that could influence the results, such as humidity, possible residues, or residue heat. And now he had a complicated graphs that were hard to understand. It had too much information. And graphs 2 and 3 showed the same result, which is quite redundant and unnecessary. He showed the accuracy twice. Thank you.
Okay, thank you. We'll now move to the discussion between the opponent and the reporter, and we have 5 minutes for the discussion.
Thank you. So our first discussion topic, did you perform experiments one right after the other because the microwave could have residue heat from previous trials?
Yes, but I had to pause this a few minutes. Yes, but I had to pause this of 2 minutes between every single.
Is there a practical reason why you chose this 2-minute mark, or is it just randomly choose?
It's randomly choose.
Okay. Did you use a thermometer to make sure that the microwave reached the room temperature?
No, I didn't.
Okay, for the next question. Do you think that taking the chocolate out in the moment you see the hot spots forming would increase the accuracy?
No, because that method enters in the category of human error. The human eye cannot perceive the exact moment, and because of that, I used certain amounts of time, 15, 17, 19, and 20 seconds, so that I could be more precisely, and the accuracy of the method would be the greatest possible.
You mentioned that different chocolate types wouldn't affect the results. Don't you think that some chocolates, because ingredients melt faster, would make the hot spots harder to see and thus decrease your accuracy?
Yes, as I stated, I could vary a lot of different things, including the chocolate ingredients. But I thought and I strongly believe that the time is the most important of them all. Because of that, I choose to vary time over chocolate.
How do you think that other parameters like variation of humidity or preheating the microwave could have shown different results?
It may could, it may didn't, but certainly I wanted to show the amount time of the exposure times, and in the following research I promise I will taking into account the variation of humidity, as you said. It would affect, of course.
Okay, another question of ours is, you said that that taking the chocolate out of the moment you see the hotspots forming would imply human error, but even though human error is indeed involved, it would generate a higher accuracy because the hotspot is more concentrated. Did you try to do this experiment?
No, I didn't, because as I said, I strongly believe that time is the best solution because we have certain data, certain amount of times. If the human error, it could vary. It could vary what the human eyes perceive of melted points when the points start to melt.
Okay, and for our last discussion topic, the frequency of the microwave, you mentioned that you didn't measure it. How could this affect your results?
Every standard model of a microwave has the frequency of 2450 megahertz. It wasn't necessary to measure the frequency.
Yes, but as I mentioned in my weak points, it is quite common knowledge that microwaves after time degrade and...
yes, I have a new one, a new microwave.
Okay, that was not the problem. Thank you.
Okay, thank you. We'll now move on to clarifying questions of the reviewer. You have 2 minutes.
Okay, thank you. I will start with a question for the reporter. How did you make sure that the microwave frequency was that of 2450 Hertz?
I didn't. I took it for granted.
Okay, thank you. One question for the opponent. How would varying the position of the chocolate determine different results?
So, as the report specified, the relative position in the microwave wouldn't necessarily have an impact because the hotspots stay the same. So you only modify the position of the chocolate. You don't modify the position of the hotspots.
Okay, thank you. And I have another question for the reporter. Do you think that using different chocolate types with higher melting points would change your results?
Yes, it would, but as I stated before, I choose to vary time, not the ingredients. And the ingredients are necessarily the best variation.
Okay, thank you. That is all.
Okay, thank you. We'll now move on to the preparation of the reviewer. In the competition, they have 2 minutes for writing their presentation and coming in front to present their opinion on the discussion. Okay, so we are ready to move to the statement of the reviewer. She will have 3 minutes.
Hello, my name is Amara Ducanu, and I will be the reviewer for problem 1 from Science Fact 1, Chocolate and Speed of Light. This is the problem's task, which you are probably already familiar with. I am going to start off with the reporter's summary. He had a lot of strong points represented by the fact that he stated the possible human errors, which could impact the measurement's accuracy. And also by repeating his experiments, the rate of error significantly decreases. And I also appreciated the fact that his presentation was very interesting and engaging because it flowed in a logical sequence. It had a strong theoretical part, and it also displayed a good range of research and investigation, and it covered most of the main points. And moving on to the weak points, they would be represented by the fact that he didn't mention the chemical ingredients of the chocolate, and he didn't vary the chocolate types. For example, certain chocolate types like Cadbury chocolate have a higher melting point, and these higher melting points result in different clarity of the hotspots. He also didn't mention how the condition of the microwave, for example, the variation in the humidity levels, or the existence of residual elements would have impacted his results. Also, the second hypothesis is wrongly stated. The data graphs were sometimes welcomes thoughts. He had a very well organized presentation. I also appreciated the fact that at a certain point, he asked the reporter about the frequency of the microwave, and he also suggested using a thermal camera. And for the weak point, he didn't ask about the height at which the chocolate was located, nor about its properties, and he also didn't ask how a microwave specifically works, and he didn't really understand that. During this fight, there were also a few clashes. For example, at a certain point, the opponent asked a question regarding the usage of a thermal camera, and the reporter responded by stating the fact that this idea was too far gone. On this, we agree with the opponent. Later on, the opponent asked a question related to the variation in the type of chocolate, and the reporter responded by stating that the weight remained the same. And while we agree with this with the reporter, we also believe that by varying the type of chocolate, other aspects of this problem could have been analyzed. Thank you for your attention.
Both the reviewer and the reporter for the wonderful debate we had today. I stand by the points I made in my presentation, but nevertheless, I think we had a fruitful debate, and the reporter should take the suggestions and use them in his next studies.
Thank you. And we'll now move on to the concluding remarks of the reporter.
First of all, I wanted to thank both the opponent and the reviewer for all of their remarks. I think they're good ideas, interesting ideas, strong points of view, and I promise you I'll take them into account in the following experiments and presentations. And who knows, maybe the possible improvement of the study. Thank you very much.
Jury members have any questions for them? If no, then I can ask a question. Emma, you mentioned in your presentation one of your last points was that he could have maybe varied the height of the chocolate. Could you maybe explain a little bit how do you think the variation of height would influence the results?
I think that varying the height of the chocolate would result in a different hotspot location and bigger clarity of the hotspot's image.
Okay, thank you.
Why do you think that the ingredients in the chocolate would be important?
I think that in certain cases, the chemical compounds of the chocolate would somehow influence the position of the hotspots, for example, or even the result. I mean, after you put the chocolate in the microwave, the state of it would be different if the compounds would be varied.
But you would still find water, right?
Yes, and the waste would remain the same, yes.
So that's
Yes.
the important part, right? Because the water molecule is important.
Yes, it is important.
Thank you.
Okay, are there any questions?
În mod normal, acum urmează jurizarea. E un anumit stil de jurizare care nu seamănă cu cel clasic. O să rog, dacă găsești un scor și să punem să valori copiii, e de fapt sistemul după care copiii își alcătuiesc lucrările respective. Jurații pun anumite note care nu sunt neapărat orientate înspre structura științifică neapărat. Bineînțeles, au o componentă puternică pe această direcție.
echipa care a reprezentat Andrei, simulând practic lupta dintre trei țări care intră în concurs. Cred că ați înțeles, da? Ideea. Acum, dacă reușim să găsim, noi avem aici niște forme de scorșituri pe care colegii noștri se pregătesc să le completeze și care sunt diferite pentru reporter, oponent, respectiv reviewer. Pondera majoră într-o competiție o are, din punctul de vedere al punctajului, o are raportorul. El este cel care trage după sine echipa sau nu. Bineînțeles, și oponența, respectiv reviewerul, contează foarte mult, dar punctajul mare este al raportorului, deci pe problemă. În fiecare an sunt, până găsește Ioana, acesta este scorșitul, în fiecare sunt 17 probleme propuse, cel puțin la fizică așa este, nu știu, la matematică, cam 10. Deci sunt niște probleme pe care voi le găsiți deja, la IYNT ele sunt afișate și din ele, logic, echipa trebuie să le pregătească în principal. Noi mergem cam pe toate. Da? Ai posibilitate să refuzi, dar după 2 refuzuri ești deputat. Deci, în principal, noi am mers cu toate cele 17 probleme rezolvate. Echipa mare a fost formată numai din 5 persoane anul trecut, pentru că am avut o problemă și n-am putut să participăm cu întreaga echipă de 6 persoane și să știți că s-a simțit. Pentru că nu ai voie să repeți un rol de mai multe ori. Din acest motiv trebuie să fie echipa completă. Ioana o să... Da, scuze. Cătălina. Ioana, prezintă puțin sus. Da? Deci o să vă rog să vă uitați puțin spre el. Vă mulțumesc pentru
Ok, deci, după cum puteți observa, în zona aceasta avem partea de notare. Cele mai multe puncte în zona de reporter se dau pentru contextul științific și pentru rezolvarea propriu-zisă, deci maxim 6 puncte. Și apoi urmează un punctaj destul de mare acordat discuției și modului în care reporterul reacționează la ceea ce se întâmplă în fight, cum își apără propria soluție, cât de convingător este și cum reușește să discute cu oponentul și cu reviewerul despre propria soluție. Apoi, trecând mai departe la oponent, se punctează critica obiectivă și cât de bine oponentul reușește să facă o analiză a reporterului. Oponentul trebuie să aducă atât puncte tari, puncte pro, cât și puncte slabe, minusuri, pentru a găsi îmbunătățiri ale soluției reporterului. Asta e foarte important. Scopul acestei discuții nu e să ne certăm oponentul cu reviewerul și oponentul cu reporterul și apoi cu reviewerul, ci mai degrabă să încercăm să găsim un consens și să găsim cu toți împreună îmbunătățirea ale soluției reporterului. Și apoi ultimul din cele 3 roluri, respectiv reviewerul, el chiar trebuie să fie imparțial și nu să se dea de acord cu unul sau cu celălalt, respectiv doar cu reporterul sau doar cu oponentul. Trebuie să găsească un mod să îi face pe amândoi și să facă un sumar al discuției, respectiv să aducă noi puncte care nu au fost până în momentul respectiv precizate. Și în felul acesta are loc jurizarea, respectiv în toate concursurile este destul de important, după părerea mea, să respecti rolul pe care îl ai. Se scade destul de mult dacă un reviewer este agresiv și devine oponent, sau dacă un oponent nu este suficient de convingător și nu aduce suficient de multe puncte de discuție. Și acum...
Bună dimineața, am vrut să vă povestesc doar foarte puțin despre IYNT, adică concursul similar de matematică, care este pentru liceu. Desfășurarea concursului este similară cu asta, cu câteva elemente foarte importante de diferențiere. Deci, să zicem, desfășurarea unei runde este quasi asemănătoare. Vine reporterul, prezintă, vine oponentul, e oponent, vine reviewerul, face sumarul discuției. Este posibil să mai fie și un observator, observator 1 sau observator 2, depinde de situație, care de obicei nu face nimic, ci doar observă. Și aici stă diferența. Ăsta este un concurs pentru copii, adică până în 16 ani dacă naște. Ăsta mare, timul, este pentru liceu. Iar există timp, aproape 48 de ore, pentru oponent să analizeze problema reporterului, despre aproape 48 de ore, pentru review să analizeze. Spre deosebire de aici, trebuie să facă un written review, adică un review scris, sub o anumită formă științifică. Review-ul scris se punctează. Dacă nu faci un review bun, poți să pierzi. De exemplu, anul acesta, echipa noastră a câștigat puncte foarte multe prin faptul că am avut un review foarte bun, un written review foarte bun la toate etapele. Deci ai mai mult timp și timpul este dat prin faptul că s-ar putea să găsești soluții ale reporterului de 30 de pagini și nu ai pur și simplu nu ai timp. Totodată, discuțiile care se poartă aici sunt de cele mai multe ori pe materialul scris, adică nu pe un PowerPoint, ci pe materialul scris și te trezești că oponentul zice, te duci la pagina 7, în rândul 15 de sus, de ce ai făcut o anumită chestie, când în loc de mai mic strict, trebuia mai mic să regale. Adică sunt niște detalii care intră, sunt unele în care pot intra foarte multe detalii. Discuțiile legate de juriu sunt similare cu cele de acum. Juriul pune clarificări, întrebări clarificatoare, dar totodată juriul întreabă și oponentul și reviewerul. Deci, toți cei trei trebuie să știe aproape foarte, foarte bine materialul scris. Dacă e un material bun, ghinionul oponentului, ghinionul reviewerului, asta e viața. Dacă e un material mai slab, ai de ce discuta. Dar dacă e foarte bun, deci cam asta ar fi. Plus că prevalarea problemelor durează cam 3 luni de zile acolo. Aproape. La noi avem dreptul să facem 6 difuzuri, deci în regulă. Rolurile nu se pot repeta în aceeași rundă. Pentru mai multe, de exemplu, pentru mai multe detalii, cei care sunteți interesați, faceți echipă și până lunea viitoare, deci luni care vine, se termină scrierile, iar marți va fi tragerea la sos, dar mai multe detalii o să vă dau și în cadrul concursului Buz Dugan, bănuiesc că mulți dintre voi este mai atunci.
Deci există mai multe concursuri de această formă. IYNT-ul, încă o dată, este orientat strict către elevii clasei a 9, pentru că încă mai aveți vârsta. Respectiv, nu ai voie în anul cu concursul să împlinești 17 ani. Toți ceilalți au început deja pregătirea, cel puțin în cadrul fizicii, pentru celelalte două concursuri, respectiv IYT-ul și IPT-ul. Am propus deja celor mari problemele. Urmează să facem selecția stabilită după 1 ianuarie pentru celelalte două. Pentru IYT, la fel, selecția se va face până în 15 ianuarie. Rugămintea noastră este să vă alegeți o problemă, una singură din cele 17, pe care să o pregătiți inclusiv cu experiment în spate. Deci, o problemă completă. Ce ați văzut acum este o problemă concepută de copii de gimnaziu. Avem alte forme pentru problemele concepute de colegii noștri care sunt în liceu și de aceea o să rog pe Darius să pună pe site-ul școlii forma, două probleme într-o formă pe care o găsit-o cei mari. Deci trebuie un nivel științific înalt, în conformitate cu vârsta pe care o aveți. Deci rugăminte, bineînțeles, redactările se vor face în limba engleză pentru toate concursurile, la fizică și probabil și la matematică. Și la matematică. Bun. De asemenea, anunțăm de acum, la nivelul liceal, mai avem un concurs, de data aceasta strict de chimie. Școala noastră a participat anul trecut pentru prima dată. El se numește la fel, numai că, deci, apare chimia, dar ICHT. A avut loc în Budapesta anul trecut, noi am participat, coordonarea a fost a doamnei profesoare Bogdaneanu. De asemenea, o să începem înscrierile și pe această direcție. Este tot un concurs la nivel liceal. Peste tot avem, bineînțeles, și ajutoare, respectiv elevii ai noștri care sunt în anul sau chiar la facultate, care ne vor sprijini și pentru aceasta le mulțumim foarte mult tuturor celor prezenți astăzi aici. să vizionați tot ceea ce școala vă oferă în aceste zile. Aveți o surpriză pregătită de copiii din clasa 11-a B, care au rearanjat sălile. În sălile emblematice ale școlii au filme prin care puteți să vedeți istoria școlii din prisma sălii respective. Este o primă încercare și, spunem noi, extrem de reușită, o idee foarte, foarte bună. Deci, sala academicienilor, absolut toate sălile, sala APAN, au filme documentare despre devenirea lor în această școală. Sunteți invitați să le vedeți, inclusiv muzeul. A fost dorința copiilor pe care am respectat-o. Mâine, de asemenea, vă așteptăm la ziua oficială, care vă este dedicată, pentru că sunteți la început de drum. O zi bună vă doresc, mulțumesc tuturor colegilor participanți.